Okay, we're going to be actually solving rational equations, which means we've got fractions in them. That's as simple as it gets. Now I want to start off with reviewing a little bit about how we would just solve a regular equation and fractions in it. Well, of course, we could change them to decimals, or we could work with them like they are, but there's a way to get rid of all of the fractions in one step. If I multiply by the LCD, let's see what happens. I'm going to multiply both sides of the equation by the LCD. Now, how did I get 20? Well, that's the least common denominator between 4 and 5. So 20 times 3/4, that'd be 4 into 20 is 5. 5 times 3 is 15, so 15x, minus 40, 20 times 2. 20 times 3/5, 5 goes into 20 4 times. 4 times 3 is 12, x. And then 20 times 1 is 20. Now we just have a simple equation to solve. Subtract 12x from both sides, and I get 3x minus 40 equals 20. Add 40 to both sides, and I'll get 3x equals 60. X equals 20. So that is one method we can use. Now let's look at another example of something we've seen in the past. X over 21 equals and actually I wrote that wrong. I wanted that to be x over 7 equals x plus 10 over 21. That makes a big difference when you write it the right way. Now, there are two ways we could approach this problem. One way we might remember is to cross multiply. This only works when you have a fraction that equals another fraction. So I would take the 21 times the x, 21x, equals 7 times x plus 10. 21x equals 7x plus 70. So I'd have 14x equals 70. So x equals 5. Now that is one method. Now another method is actually to make them have the same LCD. Very easy on this one. I could have 3x over 21 equals x plus 10 over 21. Now, since these fractions are equal and the denominators are the same, that means that the numerators also have to be the same. So 3x will have to equal x plus 10. You can also think about it as multiplying by that least common denominator. If I multiply by 21 on each side, the 21s would divide out, and we'd be left with 3x equals x plus 10. So I'd get 2x equals 10, x equals 5. This is one of my favorite methods. So if you can ever make the denominators the same, it'll make your life a lot easier. So now let's look at it with a little bit more difficult stuff. Let's start with 8 over 3x minus 2 equals 2 over x minus 1. Now, on this one, since the denominators are not even similar, I wouldn't even go there. Fraction equals another fraction. This is a perfect candidate to cross multiply. So I'd have the 8 times x minus 1 equals 2 times 3x minus 2. 8x minus 8 equals 6x minus 4. That'll give me a 2x minus 8 equals negative 4. 2x equals 4. X equals 2. Now, it is very, very, very important to check your answer here. There will be times that your answer, if you plug it back in here, this gives me a 4, that gives me a 1. I'm okay right now. But sometimes, you will get 0 in the denominator when you plug it back in, when you check. So if you get 0 in the denominator when you check your answer, this is called an extraneous solution. It does not work when it's plugged back in. So we would have to eliminate that option for an answer. So here we're okay, but we always want to check to make sure that our solution is not extraneous. So let's go with another example here. This is a good one. 1 minus 5 over x minus 20 over x squared equals 4 over x squared. Now there's several ways we can approach this. A lot of people like the idea of getting that common denominator. It really makes it easy. If I change these all to have x squared in the denominator, this would be x squared over x squared. This would be 5x over x squared. This would be 20 over x squared. This would be 4 over x squared. Now, all three fractions have the same denominator. I can combine them. All over x squared equals 4 over x squared. Now notice, this truly is an equation, and the denominators are the same, then that means the numerators have to be the same as well. X squared minus 4x minus 20 has to equal 4. That means x squared minus 5x minus 24 equals 0, and now we just have a quadratic to solve. We always try factoring first, x and x. What multiplies to give me negative 24 but adds to be negative 5? It's going to be a negative 8 plus 3. So I have x equals 8 and x equals negative 3. Look back at the original equation. Are there any possibilities I could have 0 in the denominator? Yeah. If I actually had 0, that would definitely give me 0 in the denominator. I don't have that option. So I'm good. That was not my answer. All right, last example. All right. So this is another one that, since it's not a fraction equals another fraction, the cross multiplying will not work. So let's find that common denominator. Well, it's easy that we've already got x minus 2 and x minus 2 here. So this would be 5x over x minus 2 equals 7 times x minus 2 over x minus 2, right? Plus 10 over x minus 2. Now the beautiful thing here is, if you notice up here, once we got them all with the same denominator, we really only had to look at those numerators. So here we go. 5x is going to have to equal, let's go ahead and distribute, 7x minus 14 plus 10. It's going to be a negative 2x equals negative 4. So I get x equals 2. And let's check our answer. If we plug that back in, when I plug that back in, I get 0 in the denominator. So this is an extraneous solution. Now, if we had more than one option, we would have just marked this one out and gone with the other. But on this problem, since that was our only option for answer, we get no solution.